Hello all you fine folks out there. We're looking at question 11 here on the 2003 Fermat paper put out by the wonderful folks at the Center for Education in Mathematics and Computing. They make great contests and this one's no exception. So question 11, in the diagram, it is only possible to travel along an edge in the direction indicated by the arrow. Hazel studied the figure and determined all the possible routes from A to B. So we've got an A over here, and then we've got a B over here, and she's going along all the arrows. Okay, so she might go to X, and then to Y, and then to B, or she might go A to Y to B, who knows. She selected one of these routes at random. What is the probability that she selects a route which passes through X? Okay, and then we have a whole bunch of probabilities here. Okay, I'm going to rule out C right away. C would be 100% of the time she has to pass through X, and I've already said she could go from A to Y to B immediately, and that wouldn't make her pass through X. So already I've narrowed some of this down a little bit. But it's a probability question, and there's one great way to handle probability like this to figure out how many possible ways there are to do something, and how many possible ways that we're singling out, in this case passing through X. How many possible ways are there to pass through X and go from A to B? So we're going to figure out both of those numbers, divide the smaller one by the bigger one, and we should get one of these answers, 8/11, 6/11, something like that. Okay? So, with a diagram set up like this, first we're gonna grab our pen and we're gonna copy it into our notebook. But there's a great way that we can enumerate all possibilities. So I think there's two of them going to X, and then X goes to B. And I think there was A going to Y, X going to Y, and then I think there were three separate pathways. Before I continue arrowing this, we should probably figure out... yes, I got the diagram correct. Hooray. Anyways, you've probably seen this counting method if you've ever done... there's a bunch of questions out there that show you a grid and ask you stuff like how many ways can you get from A to B only moving northeast, so east or south along the grid. And this is a great Pascal's triangle moment, but we're not going to really go into this. But if you've seen a question like this, you'll recognize this counting technique. And if you haven't seen a question like this is something to keep in your back pocket if you're given a limited number of paths on a question and you're just trying to enumerate all possible paths. You know what, I don't use the orange enough. Let's use orange. So, how many ways are there to go from A to X using only this path? Well, there's only one way. And there's only one way to go from A to X using this path. How many ways are there to get to X? One way going through this route, and one way going through this route. So there's two ways to get to X. Okay? How many ways are there to go from A to Y using only this route? Well, there's one way. Now, if we wanted to go from A to Y, just in general, not limiting ourselves to one route, we could go this way. We could go this and then this. Or we could go this one and then this one. So there's three ways. And the easy way to see that is there were two ways to get to X, and only one way to go from X to Y. That's along this pathway. And there's one way to go here. We just add these numbers up. It's great. Okay, so now we know that there's three pathways that go from A to Y. But we're trying to go from A to B. We're trying to count them all. Now, if we're going from X to B directly, so A, X, B, and we're not having any Y's at all, there's two ways to accomplish that. The two ways to go to X, and then travel along this path, and that'll get you right to B, and then you're done. Now, once we're at Y, there's three ways to get to Y, and then, so there's three ways to get to B going through Y using this route, then using this route, and then using this route. So each of these gets a 3. And now we add up everything that's going into B. There's two ways to go through X, skipping over Y, coming along this route, plus three ways to get to Y, and then use this route, three ways to get to Y and then use this route, and three ways to get to Y and then use this route. So that's a total of 2 plus 3 plus 3 plus 3 equals 11 ways to get from A to B. Fantastic. Okay. Now, what's the other part of it? It's using X. What's the probability she selected a route which passes through X? Okay. Well, there's lots of them that go through X. You know, we could go this way, and then this way, and then this way. Or we could go, you know, this way, and this way, and this way. It's probably pretty quick to enumerate all the ways that go through X. But I'm actually going to do a flip side. I'm going to say, let's enumerate all the ways that go through Y. And skip over X and just go through Y. So we're sort of forced to use this path, because we need to avoid X. And once we're there, well, we can't go backwards along this route. You know, that's a no-go. We have to proceed to B using one of these three paths. So each of them gets a 1, and that's a total of 1 plus 3 paths leading into B that do not in any way touch X. Okay? So for probability, we want the number of ways to use X and the number of ways to go from A to B. Okay? We know the number of ways to go from A to B, that's 11, but we actually don't have the number of ways to use X. You might think that this 3 here is what we need. And indeed, 3/11 is one of the answers. But I flipped it around. I said, let's find the ways to go from A to B that don't use X. So that's a smaller number. It was easier for me to count. And now if I want the ways that do use X, I know there's 11 ways in total. 3 of them don't use X, so the remaining 8 must use X. Okay? This is a great point of thinking, and it's something that comes up a lot in some of my first-year university classes. Sometimes it's quicker to count the things that don't happen and subtract them off from the total than it is to count the things that do happen. Okay? So this probability, nonetheless, it's 11 minus the 3 ways to avoid X, which is what we counted. We didn't count the ways to use X. We counted the ways to avoid X over the 11 ways to get from A to B. And that's going to be 8 over 11, and I think that was A. Let's just double check. Yes, it was. Okay. So 8 out of the 11 possible routes use X. Okay. Then there's 3 that don't use X. They just jump to Y and then go to B. Okay. So I liked that one a lot. It's got a great counting technique that does come up a lot later in math, and it does come up on math contests as well. And I liked that I threw in the count the 3 and subtract them off, because that's a good technique to be pondering. But if you just counted the ways that used X, you can still use the same counting technique, and we would have used blue pen, I guess, and you would have done 8, and you would have done 8 out of 11. You wouldn't have confused yourself at all. Okay. But that does it for question number 11, and so I'll see you guys for question number 12 in the next video.